Well, welcome you all to the next session of S.J.Sarkar's class. In the last class, actually, we had discussed about the types of the transformer. Now we'll be continuing the discussion further, and let us see that how basically the transformer is working. The fundamental operation of the transformer will be discussed, and then gradually we will be coming across the constructional details of the transformer. So what we had discussed that basically the transformer is represented like this one. So this is suppose the primary winding, and this is suppose the secondary winding while load is connected. So source is connected in the primary winding, and in the load is connected to the secondary side, and let NP and NS be the number of turns in the primary and secondary. Now just try to understand how basically this transformer operation is going to be. So ideally this is how basically we are going to have any transformer. We are having the windings, this and this, and then the two lines are representing the code of the transformer. Now when we are connecting the source to the primary side, what is going to happen? It is obvious that a finite current is actually going to flow through it. So let us suppose IP being the current. Now when IP current is actually passing through the primary side, then what is going to happen? A flux is going to be generated. Now who is going to generate the flux? Due to this current passing through the primary coil, basically flux is going to be generated in the most crude form. So let us suppose this is the flux. This is the flux phi. Now what happened? We had connected the load. We had connected the source. Some current is drawn, due to which some flux is produced. Now what is going to happen? You could see that this flux is going to link secondary as well as primary, isn't it? Because the same flux is linking with secondary and the same flux is linking with primary. So what it should happen? We know there is Faraday's law. What it was? That E equal to minus n d phi dt. So corresponding to that, we are having some time varying flux here due to time varying current IP. So there should have some EMF in the primary side as well as in the secondary side. So let us suppose this ES be the EMF that is being produced due to this Faraday's law, be this one, and the direction shows that this point will be positive, this point will be negative for positive half cycle, and vice versa. And similarly a EMF would be generated here in the primary side as well. So we are having EP and ES. So how they would be related? EP would be NP d phi dt, ES would be NS d phi dt. So what we could say there, that the relationship EP by ES is nothing but NP by NS. This is going to hold true. Now what we could see, that if some voltage is being generated in the secondary side. Let me consider the secondary side first, then we will be considering the primary side. If we are having a voltage in the secondary side that is connected, we are having a voltage. Now let us suppose initially the load is not connected. We are having a switch arrangement here and it is off. So we are having some voltage ES only. Now, as soon as we are turning the switch off, means we are connecting the load on a transformer. So what is going to happen? This ES is going to be applied across this load. Now when this load is now connected, so what is going to happen? Some current IS will now flow in the secondary side. It's okay up to this much. Now, one point what we could observe here is that this EP, the direction, see the direction of EP. According to direction of EP, this point should be positive with respect to this during positive half cycle. Now, if this is the supplied voltage Vs, it will have this point positive at the time of the positive half cycle and this point negative. So basically we could see that the direction of Vs and EP, they are opposing each other. This is what the basic observation was. Now you may ask why it is, because that is again following the Lenz's law. Because EP is due to what? It is basically due to the flux. Which flux? The flux produced due to the flow of IP. Now due to which IP is there? Due to this Vs. So Vs is mainly responsible due to the production of EP. So EP would be opposing that. And ES, it is coming to the secondary side, so it's a different issue. So what we could see here, that Vs will be equal to minus E1 here. I am assuming an ideal transformer. But if we could go to the bigger case, the cases may be different. But let us consider the ideal case first. So VA should be equal to minus E1 in that case. Now, whenever there is some current in the secondary side, what is going to happen? When a current is passing through a coil, it will produce a flux. It's obvious, known fact to us. So whenever this current IS is passing through the secondary coil, it will again produce a flux. So what would be the direction of that flux? The direction of flux will be opposite to that of the main flux, because IS is due to EH. Why EH is there? Due to phi P. So if some flux phi S is generated due to the current IS, that will be basically opposite to that of phi. So it would be again linking both primary and secondary, but the direction would be opposite. This phi S will be opposite to that of phi. Now, when load is connected, some current IS will flow, it will result some current, some flux phi S. Now, when there is some flux phi S, so what about the total flux inside the core? The total flux is going to reduce, and it would be nothing but the difference between phi and phi S. So the net flux in the core would be phi minus phi. To do phi minus phi S should be the total core, that is the total flux inside the transformer core. So what about EP and ES? So in that case, EP and ES tend to reduce because the total flux tend to reduce. Now when EP and ES tends to reduce, then what is going to happen? This VS is remaining constant. EP tends to reduce. So what is going to happen? The potential difference between this point and this point is going to increase. This point will be at higher potential and this point will be at lower potential. So what will happen? There would have some finite, if we could assume there is some finite resistance of the wire, so some current is actually going to pass, or it will allow some more current to come inside. Why? Because if this additional current is going to come inside, then this phi is again going to increase, so that this EP and ES will go to the that value where it was in the unloaded condition. So what is the overview of that discussion is, if IS increases, IP also increases. From the discussion we could see. And what about the relationship between the two? The MMF in the primary and secondary coil should be equal. This implies NS into IS should be equal to NP into IP. So from that we could say that NP by NS is equal to EP by ES, that is equal to IS by IP. Now this relationship we could know, this sort of relationship we had already come across during our class 12 course, or while we were discussing the fundamental transformer we had come across. Now what is NP by NS? This is basically the turns ratio A, or the inverse of the transformation ratio 1 by K. So that is how basically the transformer is going to operate. If I am applying some load, correspondingly there is increased current in the primary side to compensate that. Why it is happening? Due to this principle what I had told, it is going to happen. So let me stop here. We would be discussing the fundamental basic construction of the transformer, and then gradually moving towards the practical transformer after discussing the properties of this ideal transformer. So I'm stopping here. Thank you. Have a nice day.